So the next topic is about adjoint of a matrix, and just like your cofactor matrix, you'll be having adjoint for a 2 cross 2 matrix and a 3 cross 3 matrix as well. So for a 2 cross 2 matrix, relatively the adjoint is very easy. For the 3 cross 3 matrix, there is a lot of work. Right? For a 2 cross 2 matrix, what you have to do is these are the elements. We have the matrix A, which is given by A, B, C, D. A and D are the elements which are along the principal diagonal, right? So this is known as the principal diagonal. This is the opposite diagonal, right? So what I have to do in order to find out the adjoint of A, which is represented by ADJ, in short you can write ADJ, and it should be read as adjoint. So adjoint of A, in order to find out the adjoint of A, what you have to do is you have to switch the elements which are along the principal diagonals. So AD is going to become B and A. The other elements, the other two elements, the signs are going to change. Meaning that I'll be multiplying with -1, right? So that is what I have to do. Now, let me take a simple example over here. This is the question, right? This is from the first exercise. Find the adjoint of the matrices in exercise 1 and 2. Yes.
3 minus 3 1.
Exactly. So the adjoint of A is going to be equal to the principal diagonal elements have to be shifted, and here I have to multiply by -1, and I will be getting my answer, right? So this is going to be your adjoint of A for your 2 cross 2 matrix. I think this is very easy, right? Now let's talk about 3 cross 3 matrix. Even that is very easy. In case you know about cofactors and minors, right? It is very easy. So first I'll define how adjoint of matrix is taken for a 3 cross 3 matrix, right? So if I have a matrix A and these are the elements, right? The adjoint of a 3 cross 3 matrix is going to be equal to the transpose of the cofactor matrix. So yesterday I told you about the cofactor matrix, right? So you have to find out the cofactor, you have to transpose it. Transpose this particular matrix, right? Transpose as in the rows will be shifted to columns, or columns is going to be shifted to rows. That is what you have to do, right? So let's see how we can do that using an example, and I think this is your second question from the exercise, right? So we have to find out the adjoint of the matrix 1 and 2. 1 I have already done. This is the second one, right? So I will start by taking the matrix. This is going to be A. I will name it as A. So the same matrix has been taken. Now I have to find out the cofactors and minus both have to find out, right? So I will start by taking C as the cofactor matrix, right? Let Ij represents the number of rows and number of columns, right? Now, first, this is the particular element. So I will start by finding out C11, the cofactor for the first element, right? So what I have to do, I think yesterday I have told you 1, 1. So you have to close the first row and the first column. First row and the first column, if you close, you will be getting this particular matrix 3, 5, 0, 1. This one, yeah. So you take the determinant of the same, 3 multiplied by 1 minus 0 multiplied by 5, you will be getting the answer as 3. Right? So this is going to be the cofactor for the first element. Similarly, you can find out for the second element. This is going to be C12, right? First row, second column you close, you will be getting these matrices. 2 and 5 will be left out, -1 and -2 and 1, right? Now you take the determinant of the same, 2 multiplied by 1 minus -2 multiplied by 5, you are getting your answer as positive 12, right? I have not changed the signs yet. I will do that later, right? Now, coming to C13 for the third element, right? So I should close the first row and the third column. I will be getting this particular matrix over here: 2, 3, -2, and 0, right? So this is what I will be getting, and now I have to take the determinant of the same, and it is 2 multiplied by 0 minus -2 multiplied by 3. I will be getting my answer as positive 6. Now, coming to the second row and the first column. For this particular element, it is going to be, you have to close the second row and the first column, -1, 2, 0, and 1. Again, you take the determinant, -1, 1, 0, and 2, you will be getting -1. Right? Similarly, for the middle one, C22, you have to close the second column and the second row. Both of them, you will be getting the last elements, the outer elements, 1, 2, -2, and 1. The same elements has been taken. Again, you take the determinant of the same, 1 multiplied by 1 minus -2 multiplied by 2, that is going to be 5. Right? Similarly, you take for all of them negative. Next, it is going to be C23, right? as in the second row and the third column you close 1, 0 and negative 2, 1. The same has been taken. The determinant you take, you will be getting the value as negative 2. Similarly, for the third row now. The third row, first column, you will be getting negative 1, 2, 3 and 5. Now you take the determinant, it is negative 1 multiplied by 5 minus 3 multiplied by 2. So it is going to be negative 11. Right? Next, it is going to be for this particular element C3, 2. The third row and the second column will be left by 1, 2, 2 and 5. Right? You take the determinant and you should be getting your answer as 1. Next, we have C3, 3. Right? So for this particular element, you close the third row, the last column, the third column, and the third row, you'll be getting 1, negative 1, 2, and 3. You take the determinant of the same, you should be getting your answer as 5. Right? Now, I have found out all the cofactors. Right? Now, in order to find out the cofactor and the minor, both of them, like the cofactor matrix altogether, what I need to do is I should take the matrix as this. So this is the answer that we have got from over here, from here, right? So the same thing, 3, 12, 6, 1, 5, negative 2, negative 11, 1 and 5 has been written down in form of a matrix, right? Now I have to change the signs according to that convention, right? Positive sign, negative sign, positive sign, negative sign, positive sign, negative, positive, negative, and positive. Let me place this over here, and this is going to be the matrix. Right? Now, I have to take the adjoint of the same in order to get, sorry, I have to take the transpose of the same in order to get the adjoint matrix. Right? So this is your cofactor matrix. You change the rows to columns or columns to rows, you should be getting your answer. Right? So the adjoint of matrix is given by the transpose of cofactor matrix. I have found out the cofactor matrix. Yes. So it is going to be 3, negative 2, 12. The rows has been written down as columns, and that is going to be our final. Come again? Yes. This one. Negative. Minus, because negative sign, positive sign is going to be negative sign. Right? So the same thing has been placed. Okay?
There's like only one six, so there are two.
Okay, I think this should be 2. This is 2 then. Okay? We change this one.
Yeah.
This is 2. I will make a change. I think this should be. So this is how you'll be finding out your adjoint. Now, I will give you a few questions and I will give you a time. This is one.